questions number 8 and 9. It says write each in their equivalent form, do not solve. Okay, so you don't have to solve it, you just have to write it in equivalent form. So if we look at this first one, write log base 2 of 64 equals x, and it's an equivalent exponential form. So what I do is find the base, which is 2, raise it to whatever's on the other side of the equal sign, which is x, and it's equaling this value right here, which is 64. So 2 raised to the x equals 64 is log base 2 to 64 equals x in its equivalent form. This next one starts with exponential form, which is b raised to the third equals 456. So you write out log, the base is b, you write the value on the other side of the equation, which is 456, and that's going to equal the exponential value of 3. Okay, so that's 8 and 9. Let's look at number 10. Number 10 says evaluate each logarithmic expression. So to do this, what I'm going to do is rewrite it in exponential form. So number 10, the base is 5, so because it says log base 5. I'm going to raise it to, there's nothing there, so I'm going to call that x. So 5 to the x equals, now I write this value here, which is the 5th root of 5. Okay, so if I rewrite this, I can get 5 to the x equals 5 raised to the 1/5 power. When the bases are the same, we can just set the exponential values equal to each other. So x equals 1/5, and I'm done. Okay, number 11. Again, we're going to rewrite this. So log base 3 of 1/81 equals x. So the base is 3. So 3 raised to the x equals 1/81. Now, I want to write this so the bases are the same so I can set the exponential values each equal to each other. So 3 raised to x equals 3. Now, 81 is 3 raised to the, hold on a second, 3 raised to the 4th value. So because the 81 is down in the denominator, I'm going to use a -4. So 3 to the -4th will give me 1/81. So now that the bases are the same, I can say that x equals -4. All right, next one. This one says log. It doesn't show a base, but it says 1,000. When it doesn't show a base, the base is 10. Raised to the x equals 1,000. So now I got to write 1,000 as a common base. So base 10. 1,000 is 10 to the third. Now the bases are the same. So I read off the exponential values, x equals 3, and voila, I'm done. Okay, for this next one, when you have ln next to e, they cancel each other out because they're inverse operations. So the answer is just the exponential value, which is 4x. Okay, so that was 10 through 13. Okay, I guess I skipped 14 and 15 some weird way, but we're going to go with it. For questions 16 and 17, use the properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. Okie dokie. So if I'm going to expand this out, I first see there's the major thing here is division. So I'm going to write this up as log base 6 of x squared y minus log base 6 of z to the 6th. Now I'm going to work on this one because I can break this up because they're multiplied together. X squared is multiplied by y. So if I break this up, it becomes log base 6 x squared plus log base 6 y. And then I'm going to go ahead and bring this 6 down. So I'm going to bring -6 log base 6 of z. Okay. Now I have one more little thing to do, and it is to take care of this x squared, exponent 2. So remember that can be brought down in front. So 2 log base 6x plus log base 6y minus 6 log base 6z. And that will give you the answer for number 16. Okay, number 17 is a little bit easier. It's just 2 multiplications. 4 times the square root of x inside of there. So we're going to add. So log base 7 of 4 plus log base 7 of the square root of x. Now remember, I can rewrite the square root of x by writing this up as x raised to the 1/2 power. Now I can take care of that little 1/2 and bring it down front. So this becomes log base 7 of 4 plus 1/2 log base 7 of x. And that is finished. Okay, thanks for watching. I'm going to go ahead and pick up on 18 in the next video.